Hello children, good afternoon. Today we are going to learn the next part of the lesson acids, bases and salts. I am sure all of you must have recorded your classwork, the one which we have sent through the WhatsApp. Now we have finished learning about acids, its classification, and also about bases. Now the next part what we need to learn is about salts. Before we go towards salts, let me first tell you about the universal indicator which we were discussing in our previous class. What is this universal indicator? This is the one. We know that by using various indicators like blue litmus paper, phenolphthalein or methyl orange, we'll be able to find out the given solution whether it is an acid or base. But we also have learnt about various classifications of acids, saying that strong acid, weak acid. We also learned some bases are strong bases, some are weak bases, and we also have learned that there are solutions which are neutral too. So if a colorless solution is given to you, how to find out whether the given colorless solution is a strong acid or a strong base or a neutral solution? So for this purpose we have a special indicator called as universal indicator. Now this universal indicator is made out of a mixture of several indicators. Several different types of dyes are mixed, and from that universal indicator is prepared. You can see in the picture a yellow paper which is a small strip. This is called as universal indicator. It will be available in the laboratory. Like how we use blue litmus paper or red litmus paper, we also can use this universal indicator to find out the strength of the given acid or a base. Now, this universal indicator is used to find out the strength. It means number of hydrogen ion concentration. Suppose if hydrogen ion concentration is more in a given liquid, we know it is acid. Like litmus paper, this helps us to find out whether it is an acid or base, and also apart from that it helps us to find out how strong is the acid, how strong is the base. Looking at the tabular column, you will understand if the given solution, if you dip this universal indicator, if it turns dark red, then the solution given should be a strong acid. If when you dip this indicator into a given solution, if it turns to orange red, that means the solution which you have in hand is a weak acid. Suppose if it turns to be green, then the solution should be neutral solution. If the solution turns the indicator into blue color, it's a weak alkali, that is weak base. We know bases which dissolve in water, we call them as alkalis. Suppose if the paper converts into violet color, then it is a strong alkali. Now look at the pH paper. This pH indicator tells you how strong or how weak the acid or the base is depending upon the colors. Now the pH paper is made into small segments and it ranges from 0 to 14. The center we find 7. If the universal indicator converts itself into green color, it shows the pH is 7 and the solution is a neutral solution. Same way, Say for example, we'll take up an example and learn this. Suppose if you are given lime juice, you take the universal indicator and dip it into lime juice. We know lime juice is a strong acid. So what happens to the indicator? It will convert into red color. It just transforms into red color. This shows that the solution which is there in your hand is a strong acid. The lemon juice will convert into red color. Its pH is actually between 2.2 to 2.4. Suppose if you are given tomato juice is not very acidic, it is moderately acidic. If you take the indicator, universal indicator, and dip into tomato juice, it changes into orange color, and the pH would be something between 4 to 4.4 or 2 to 4. It would be between 4 to 4.4 actually, and orange color normally denotes the given liquid is moderately acidic. Suppose you are given a solution, and if it is tap water, what happens if you dip universal indicator into it? It changes into greenish yellow or slightly greenish color, because tap water is normally pure and it is neutral in its pH range. Now, if sodium hydroxide is given, which is a strong base, then the universal indicator will change into violet color. Here I would like to give you the pH values of various solutions. Please make a note. Gastric juice pH value is 1.4. Kindly note so that the questions raised later after the class, you can use this range and answer the questions which you are going to take after the class. Gastric juice, it is 1.4. Lemon juice, the pH is 2.5. Vinegar is 4. Tomato juice is something between 4.1 to 4.4. Coffee, people say we should not drink coffee much. It's only because it is also slightly acidic and its pH is 5. The soft drinks, what you take. Soft drinks, we learnt that carbon dioxide will be mixed in the soft drink and such things. It is also slightly acidic and its pH is 6. Milk is mostly neutral and its pH is 6.5. Pure water pH would be 7. Now, you must have heard people telling you that you have to brush your teeth after every meal. It's because we have to always keep our mouth into pH between 7 to 7.4. Now, saliva, which is being secreted by the salivary glands, its pH would be 7.4 before your meals. Before you take meals, if you test the saliva, its pH would be 7.4. After meals, normally, whatever food we eat, the salivary juice will be trying to digest all the starch in the mouth itself, and so to convert it into sugars. So during that action, the saliva becomes acidic, and so after meals, the saliva's pH would be 5.8. We also have many more liquids in our body. Say for example, blood. Blood, it's 7.4, means it is neutral. Now, how about other food materials? Say for example, eggs. Eggs pH value is 7.8. Now, toothpaste pH value is 8. Baking soda is 8.5. And now dilute sodium hydroxide, the pH value is 13, whereas concentrated sodium hydroxide pH value is 14. From this you will understand that various liquids have different pH based upon the presence of hydrogen concentration, hydrogen ion concentration, and its acidity, strength of acidity. Now, looking at the picture here in the PPT, you can see our body works between pH 7 to 7.8. In case the body's acidity increases, immediately there will be a disturbance in our stomach and there would be different kind of disorders. So always the body pH should be maintained between pH 7 to 7.8. Now, you know air is a mixture of gases. The second point says rainwater pH is 5.6 acidic. That's because you know the air is a mixture of gases, contains carbon dioxide, sulfur dioxide, nitrous oxide, nitrogen dioxide. So when it rains, the water dissolves the acids which are there in it, and while it falls down as rainwater, it converts into acidic water. As such, rainwater is pure, but while it dissolves the minerals which are there in the air, it becomes acidic. Now, our stomach has hydrochloric acid. The stomach walls produce hydrochloric acid to help us in digesting the food what we eat. So, acid is present in our stomach. Now, regarding tooth decay, we'll see in the next slide. So, from this we understand pH is very important in our everyday life. Whatever we are using would definitely contain the pH range, and we must always try to see that neutrally, that is pH 7 is always safe, not only for human beings. Let's see for who all the pH 7 becomes necessary from the next slide. Now, pH in the role of pH in daily life. From the picture, you can see something very interesting on the top, that is coronavirus. This is the one which is point of discussion nowadays. What has pH to do with coronavirus? Yes, one of the conditions for this fusion of coronavirus with human cell is low pH. Yes, coronavirus will survive happily if the human cell is more acidic. Suppose if a patient experiences coughing, they know, we must have heard how the symptoms would be. If the patient experiences cough and has some trouble with the breathing, that means he is not able to expel or give out the carbon dioxide after respiration. During respiration, you take in oxygen and give out carbon dioxide. Now, when there is a breathing trouble, his or her carbon dioxide level in the body will rise. What happens when the carbon dioxide level increases? The pH will decrease. When the pH decreases, it increases the acidity. So, this will provide better condition for coronavirus to fuse with the human lungs, and this will increase the level of carbon dioxide and therefore affects the person very badly. That is why they keep telling you to do lot of breathing exercises in such a way that the carbon dioxide which has to be emitted out should be freely coming out from the body, so that the acidity is not increasing in the lungs. So here we understand pH also gives way for dangerous viruses into our body. So our pH has to be maintained. Now, as I told you, food is inevitable. We have to eat food and that needs to be digested, and when you just look at the range of food what we eat, there are certain foods which could be easily digested and certain more which needs lot of um, the emulsification and things like that to make the food easily being digested and absorbed. So here acidity, the acid is being poured out from the stomach walls, the HCl, which helps us to digest anything and everything what we eat. So again, pH has to be maintained here too. In case if you overeat, if the pH becomes more, immediately the person will suffer from acidity. At that time, doctor provides them milk of magnesia, which is nothing but magnesium hydroxide. Now what happens here? Acid is treated with a base so that the acidity gets neutralized and we get great relief. Milk of magnesia is nothing but a base. Same way, the third point shows soil and plant growth. Yes, the soil pH also should be 7. If the pH of the soil is 7, that helps the plants to grow well. In case if the pH increases, the soil becomes acidic. In case the pH of the soil decreases, the soil becomes alkaline. Either way, it is not good for the plants to grow. If the plants have to grow healthy way, it needs the soil should be maintaining a value of 7. How to know whether the soil's pH is 7 or not? A sample of the soil can be taken, dissolved in water, and we filter the water, and if we just use the universal indicator, we can easily check whether that particular soil which you have taken is acidic or basic. Now, okay, if it is stomach and acidity is formed, you use milk of magnesia and that is easy for us to neutralize it. How about soil? What to do if the soil becomes highly acidic or basic? Now for everything there's a solution. If the pH of a soil is near 7, I said it is neutral. If it is acidic, the use of fertilizers, this, how does it become acidic? It is because the fertilizers and things like that are used. If the farmer finds that the soil is too acidic, immediately he treats his soil using quicklime, that is calcium oxide, or slaked lime, that is calcium hydroxide, or chalk, that is calcium carbonate, or they all are bases. When these bases are being strewn on the soil, when it mixed up with the soil and when the soil is watered, it neutralizes the soil and that will help the plants to grow properly and in a healthy way. Okay, if the soil becomes alkaline, it is all because of the, if it is acidic rain or due to the various reasons, soil may become alkaline too. In case if it becomes alkaline or basic, what does the farmer do? He adds decaying organic matter such as manure and compost that contains lot of acidic material in it. So by adding this and again watering the soil, it will raise the basic soil into normal neutral level, and so again soil can be used for the plants to grow. So for a plant, proper growth of the plant, the soil should also maintain a pH of 7 and that should be taken care by the farmers. Now, survival of animals and humans, even that depends upon the role of pH. Now, take about the tooth. You can see the picture of a tooth here. The tooth is made up of the hardest substance, the enamel. The outer cover of the tooth, the enamel of the tooth is the hardest substance in our body. It is made up of the compound calcium phosphate. Children, this is a 1-mark question. What is the enamel of a tooth made up of? It is made up of calcium phosphate. Now, this calcium phosphate is insoluble in water. The tooth decay, it will start only when the pH of our mouth falls below 5.5. This is because the acid which is produced in the mouth will become strong and it will attack the enamel of our teeth, and so the pH of the mouth will reduce from 7 to 5.5 or below 5.5. All this happens when we eat food containing sugary substances such as sweets, candies, chocolates. So our mouth will break down the sugars in these foods and produces lactic acid. This acid will lower the pH in the mouth, makes it acidic. So this will result in tooth decay. That is why we are always told whenever we take food, immediately we have to brush our teeth. Now, how does the brushing help us? It's not only removing the particles in between the teeth, but still, when we use toothpaste, the toothpaste are made up of basic substances. The pH of a toothpaste would be always 8. 8 would be the pH of toothpaste. That means it is a basic substance. When you use toothpaste and brush your teeth, the acidity present in the mouth can be reduced, it could be neutralized, and we will not have any problem with the tooth decay. The enamel will not be disturbed in any way. So, pH has a very big role in our daily life. Now, we have learnt about acids, bases, and also a little about pH, which is necessary for us to know all about a given solution, whether it is acidic or basic. Now, we are going to learn about salts. As far as the 10th standard is concerned, we are given 6 different salts to learn in detail. The textbook contains only the preparation and uses of 6 different salts, but we also need to know about the classification, family of salts, and also the various properties of the salts. Now, when you look at the screen, you know I'm talking about the classification of salts. I've already given you classwork. I request you to take out salt families page. Here we'll discuss about the salt families. I've just given a few on the screen, and when you look at the tabular column given in the classwork, it will be easy for you to understand. Now let us first know what a salt is. Salts are ionic compounds. What are ions? We know ions are nothing but the positive charged ions are cations, negative charged ions are anions. When this NaCl, for example, Na is a positive charged cation and Cl is a negative charged anion. So a salt is made up of one cation and an anion. How do you classify salts? I gave you how salts are formed. In your classwork, you have, just before writing about salts, I gave you 3 ways of how the salts are formed. The first one, by neutralization of acids and bases. Second way, by the action of active metals on acids, or metal carbonates and bicarbonates acids, and also the action of metals on alkalis. These are the various ways from which we can prepare salts or salts are formed. Now, to know the classification of salts, it is very much necessary for us to look at the formula of the salts. As this is not given properly in your textbook, I have given you the tabular column. Now, when you look at the formula of the salt, you can find out whether it is from a strong acid or a weak acid, or from a strong base or a weak base. Based on the acids, salts are classified as chloride salts, nitrate salts. Now, salts which are formed by the reaction of, I just gave 2 examples in the screen. salts which are formed by the reaction of hydrochloric acid. Suppose if hydrochloric acid and sodium hydroxide react with each other, we know a salt and water will be formed. So here sodium chloride. When you are given a salt, sodium chloride, you must know the parent compounds. You must be able to understand that chloride, if it is there in a given salt, this has come from hydrogen chloride, hydrochloric acid. And sodium, if it is there, and well-known base is sodium hydroxide. So that is how when we look at the salt, we will be able to find out how the salt has been formed. Now sodium chloride, ammonium chloride, calcium chloride, aluminum chloride, magnesium chloride, copper chloride, these are formed when a base reacts with hydrochloric acid. Base reacts with, if it is sodium hydroxide and hydrochloric acid, you get sodium chloride. These, suppose if the reaction takes place between a base and a nitric acid, you get nitrates. Sodium nitrate, potassium nitrate, ammonium nitrate, calcium nitrate, magnesium nitrate. This is the list what I have given you in the classwork. Suppose if a base reacts with sulfate, say sulfuric acid. Sulfuric acid has the radical sulfate. So all the salts which are formed by the action of a base with sulfuric acid will have the sulfate radicals. Sodium sulfate, potassium sulfate, ammonium sulfate, calcium sulfate, magnesium sulfate. When you look at this list, you can understand these salts are formed when a base reacts with sulfuric acid. Same way carbonates. When you have the formula CO3, immediately you must understand this has been formed by a base reacting with carbonate. Okay, H2CO3. Now, normally only till phosphate we have, but still to be on safe side, I've given you oxalate and acetate salts also. If phosphoric acid H3PO4 and a base react with each other, you get phosphate. If oxalic acid, that is COOH taken thrice, oxalic acid reacts with a base, you get oxalates. If acetic acid reacts with a base, you get acetates. That is how you get a family of salts. Now, you just see the tabular column horizontally. Sodium salts, sodium chloride, sodium nitrate, sodium sulfate, sodium carbonate, sodium phosphate, sodium oxalate and sodium acetate. All these are from sodium. So which call this as sodium family. They are sodium salts. Potassium family, potassium chloride, potassium nitrate, potassium sulfate. Ammonium chloride, ammonium nitrate. So looking at the tabular column, you must be able to understand what these salt families are. When you learn this way, you will be able to know the formula also easily. As soon as you get the textbook, we can first write down the list of all the compounds which are given in all the 5 lessons, and we first learn the formulae. From the formulae, we will be able to easily crack any question given to you. So to make you understand about salt families, I have given you this slide. Now I tell you, we have 6 salts which we have to learn in 10th standard, which are very easy, at the same time absolutely important. Any board paper will definitely have either the preparation of any one of the salts or the formula of any one of the salts, or it may ask about the uses and so on. So definitely 1 or 2 questions based on different types of salts will definitely appear in a board paper. So you have to give due importance to all the salts. Now today we are just going to learn about 3 salts. First one, very important and easy and to remember, is sodium chloride. Now we all know sodium chloride is nothing but the common salt what mummy is using in the kitchen, and the formula is NaCl. You must, by looking at the pictures here, you can understand what and how the salt could be prepared. Now And the first picture shows you Tuticorin, the seashore where the salt beds are being laid. Now, the preparation of sodium chloride. How is sodium chloride prepared? The important sources for the common salt are seawater, rock salt, and inland lakes. How is sodium chloride prepared from the seawater? We know seawater contains lot of salt. It has number of salt dissolved in it. But we won't be knowing how to take out this, particularly the sodium salt. But we people of Madurai must have definitely visited Tuticorin, and you must have seen the salt beds over there. What do? They extract salt from the seawater. How do they do it? They trap the seawater in large shallow pools. The water is allowed to evaporate by itself with the hot sun in presence of sunlight and also wind. So the common salt is left behind. After the salt is being collected, of course there would be some impurities and there will be other salts like magnesium chloride, magnesium sulfate. So the salt will be removed, will be taken, and it will be purified and supplied. So that is the first way of preparing common salt. Common salt, the first source is seawater. Now the second one, that is rock salt. How do you get this rock salt? Beds of rock salts are formed due to the drying up of seas from very old time. You can see the picture in the PPT. The seas, stalactites we call it as, the sea when it dries up, water will be completely gone. It takes lot and lots of years, like how the petroleum is formed under the sea. Even when the sea dries up, for various reasons, the salt alone remains back. This salt is dug out, it is pumped out, it is dissolved in water by first sinking number of concentrate pipes into the salt bed, and the impurities are removed, and then you get the rock salt. So the rock salt is obtained from the drying up of the seas. Now what are inland lakes? This is again another source for sodium chloride. The salt, sodium chloride. The lakes which we have, say for example the big lakes like Sambar Lake in Rajasthan, Great Salt Lake in USA, or Lake Elton in Russia. These are some examples wherein the salts are obtained by natural evaporation of water. By natural evaporation of water, the salt remains in the lake and that will be removed, purified and used. So sodium chloride, NaCl, we get NaCl naturally from seawater, rock salt, that is from drying up of the seas, and from the inland lakes. So this is very easy for you to remember. Now how is sodium chloride used? As you know, sodium chloride is highly essential in our diet, and this becomes the raw material for preparing so many different types of compounds. All sodium compounds which are very useful to us are prepared from common salt, like sodium hydroxide, sodium carbonate. Even the hydrochloric acid is prepared from using sodium chloride in industries. Now this is as you know, it is also used as a preservative. Pickles to preserve meat, fish, sodium chloride is used. Same way, sodium chloride is used in manufacturing soaps, and in pottery to give that shine, the glossiness. The pottery, you can see the picture over there. The pottery glaze is obtained. The pots get the glaze by using sodium chloride only. And apart from that, when there is cold season, almost in countries like abroad, the ice will be collected on the roads during winter in almost all cold countries. There, they strew the sodium chloride, and immediately that will help them to remove the ice on the roads. It helps in melting ice. And as you know, It is used in cooking food, and also to improve the flavor of food, sodium chloride is used. And the formula of sodium chloride is NaCl. So you've got information about the first and simple salt, sodium chloride, which is very, very useful and has properties like you must have seen common salt. It's normally it's a colorless crystalline solid. It has a melting point something about 820 degrees centigrade. It is soluble at room temperature. It is soluble in water, and if you heat sodium chloride, you get a cracking sound. Now it is slightly hygroscopic. That means it takes up water from the air and it becomes wet. If you just keep sodium chloride outside open to air, you can see it becomes slightly wet. It absorbs the mineral salts and also water from the. These are the properties of sodium chloride. Now, children, will be going for the next salt. This is very, very important, and it is sodium hydroxide, which the other name for sodium hydroxide is caustic soda. CausticSoda. Caustic soda. And the chemical formula is NaOH. NaOH. It's an important base. It is used for making all other chemicals. It is used in very long range of industries. Lot of industries, sodium hydroxide is used. Now looking at the picture, you must be able to understand that we are going to discuss about the preparation of sodium hydroxide. Now, just now we saw sodium chloride. It is we obtain from the nature through seawater. Now, sodium hydroxide is obtained from by using sodium chloride as one of the most important raw material. The main raw material for the manufacture of sodium hydroxide is sodium chloride. Now this is manufactured by the electrolysis of aqueous solution of sodium chloride. What is aqueous solution? It is nothing but dissolving a given salt in water. When electric current is passed through an aqueous solution of sodium chloride, it decomposes to form sodium hydroxide, chlorine and hydrogen. This is a simple reaction but is very, very important. This is called as chlor-alkali process. The name of this process is chlor-alkali process. Look at the picture. Sodium chloride is taken in the form of a solution, aqueous solution. Aqueous means dissolving the given salt in water. And two rods, and this copper rods are used as the electrodes. They are connected to the battery and electricity is passed. When electricity is passed, current is passed through the aqueous solution of sodium chloride. Hydrogen ion first moves towards the negative electrode. We know hydrogen ion is the cation. Cation moves towards the cathode, and anion, that is the chlorine. Here, when sodium chloride is dissolved, you have sodium, chlorine. From water you have hydrogen and hydroxyl ion. Four different ions will be there in the aqueous solution. Sodium is a positive ion, hydrogen is a positive ion, chlorine is a negative ion, hydroxide is a negative ion. Now, what happens is the hydrogen ion moves towards the negative electrode, cathode, where it gains an electron to form hydrogen atom. Hydrogen atom is H2. So, two hydrogen atoms will combine to form hydrogen gas. On the other hand, chloride ions, this moves towards the positive electrode, that is anode. Chloride is the anion. It moves towards the anode, where they lose electrons. These electrons are utilized by hydrogen and chlorine gas is formed. Two chlorine atoms will combine to form chlorine gas. So, At cathode, you get hydrogen gas. At anode, you get chlorine gas. So from all the 4 different radicals which are present in this aqueous solution, sodium, chlorine, hydrogen, hydroxide, hydrogen and chlorine are collected at the cathode and anode. Now, in the solution you have sodium ions and hydroxide ions left. They combine with each other and form sodium hydroxide. So the sodium hydroxide solution is formed near the cathode. This method is called chlor-alkali process because you are getting chlor, that is chlorine, alkali, that is sodium hydroxide. This is a very, very important reaction and preparation. So it's actually 3 products you get from this particular preparation: hydrogen, chlorine and sodium hydroxide. These are collected, they are stored separately, they are just to avoid further reaction. Sodium hydroxide and chlorine, they combine together to form sodium hypochlorite. To avoid all such things, sodium hydroxide is collected separately, hydrogen is collected separately, and chlorine is collected separately. The color of the chlorine gas would be green. And you know, hydrogen gas, we can understand the collected gas would be hydrogen with the test what we have learned before. When you bring a burning splinter near the hydrogen gas, it will give pop sound. It will put off the fire. So that is how you get 3 different products from chlor-alkali process. Chlor-alkali process is a 5 marks question, and in 1 mark question you will be asked what gas would be collected at anode or what gas will be collected at cathode. Another 1 mark question is what is used to prepare sodium hydroxide. And one more 1 mark question what we normally get from this chlor-alkali process is what is brine. What is brine? So from this you understand the preparation of sodium hydroxide. Uses of sodium hydroxide. Sodium hydroxide is used in the preparation of soaps and detergents. And as the slide shows, in oil refining and also in the manufacturing of PVC and in the pesticides. So pesticides are sprayed to see that the plants grow well. So sodium hydroxide is used in, and not only this, it's also used in paper industry, and it's mainly used in the lab as a reagent. And sodium hydroxide is also used for making cotton to make it receptive for the dyes. That is called as mercerizing cotton. And for degreasing metal, suppose if there is a grease on a metal, sodium hydroxide is used to degrease the metals. So you have learnt about the second salt now, sodium hydroxide, NaOH. The third salt what we are going to learn is about bleaching powder. You must have seen bleaching powder being used at home. The chemical name for the bleaching powder is calcium oxychlorine. Calcium oxychloride is nothing but CaOCl2. This is the formula for calcium oxychloride. Chemically, bleaching powder is prepared by the action of chlorine on slaked lime. You look at the screen, you can see the equation. The chlorine which is obtained from chlor-alkali process is used for the preparation of bleaching powder. Calcium hydroxide is taken, the chlorine is passed through this calcium hydroxide, which is also called as dry slaked lime. When it is passed through dry slaked lime, bleaching powder will be prepared. The chlorine combines with calcium hydroxide and forms calcium oxychloride, which is nothing but bleaching powder. Along with that, water would be formed. The solution will be milky due to the presence of some unreacted lime too. It will be allowed to settle down, and bleaching powder will be filtered, dried and used for further purposes. And bleaching powder is used for bleaching cotton, linen, in cloth industries, in textile industries. It is also used to bleach paper to make the paper glow and become white. Even in printing press they use bleaching powder, and it's also used as an oxidizing agent in chemical industry. It is used as a disinfectant in converting. You must have heard that chlorine is added to drinking water and to purify. That is nothing but bleaching powder. uh, in chemical industries it is used as an oxidizing agent for disinfecting drinking water and also for the manufacturing of chloroform. So this is the third salt which we have seen. I think by learning all these three different salts, you will be able to understand how the salts are prepared and what are the uses. I'll come back to you with the properties of all these three salts and then take up the next three salts. Before that, see that you go through the slides, and in case if you have any doubts, kindly post it to my personal number. Thank you very much, and revise the lesson along with the classwork. I have given you important things which are not there in the classwork, so that you are not there in the textbook, so that it would be highly helpful to you. All the best, children. Thank you for your patient listening.